Welcome to the NTSB webinar presentation, Collision Avoidance Systems, Why You Need Them in Your Trucks Today. I'm Amy Terone from the NTSB Safety Advocacy Division in the Office of Safety Recommendations and Communications, and I will be your moderator for today's webinar. Our webinar will run 1 hour and will be recorded. You have all joined this webinar in listen-only mode, which means all attendees have been muted. Please ensure as a double check you are muted on your end. Today we'll be hearing perspectives from industry and the NTSB on the benefits and use of this technology. We'll feature presentations from Insar Becik from the Office of Highway Safety, Ross Frote from the American Trucking Association, Todd Porter from Sentinel Transportation LLC, Robert Haig from Perfect Transportation LLC, and finally Anjali DeGrasse from the Teamsters Union. A special thanks to the American Trucking Associations for working with us to bring you this webinar, and all the operator reps for sharing their unique insights and data. As this webinar goes on, feel free to type questions into your tool panel at the right. We'll try to get to most of them after all of the presentations. Also, in the handout section of the webinar taskbar, we have put several documents containing useful information on this issue, some of which will be discussed today. Now, we have a lot to cover in our 1 hour, so let us begin right away with opening remarks by the Honorable NTSB Board Member Earl Weener. Member Weener?
Thank you, Amy. I'd like to talk about the reasons for conducting this webinar. Motor vehicle crashes are a leading cause of injuries and fatalities in the U.S. In 2017, more than 37,000 people died in crashes, according to NHTSA, the National Highway Traffic Safety Administration. There were more than 4,800 large trucks and buses involved in fatal accidents, up 9% from the previous year, 2016. Collision avoidance systems warn drivers of an imminent crash and can stop or slow the vehicle before a crash occurs. They include a variety of technologies that prevent or mitigate crashes, including forward collision warning, lane departure warning, blind spot detection, adaptive cruise control, and automatic emergency braking. At the NTSB, we've promoted the benefits of these systems since 1995, when we first issued recommendations regarding these technologies. Specifically, we've advocated for forward collision warning and automatic emergency braking, AEB, which together make the forward collision avoidance system. These systems compensate for human error by warning the driver of an imminent crash and stopping, or at least slowing, the vehicle before impact. In 2015, the NTSB completed a special investigation report entitled The Use of Forward Collision Avoidance Systems to Prevent and Mitigate Rear-End Crashes. This study looked at the benefits of collision avoidance systems, and it's included in your webinar documents. We reviewed several commercial vehicle investigations and concluded that many of them would have been prevented, or at least mitigated, had these systems been installed in the accident vehicles. Specifically, we found that driver inattention played a critical role in 9 crashes we investigated between 2012 and 2015. In these crashes, drivers failed to respond to obstacles ahead of them, resulting in 90 injuries and 28 fatalities. In 2012, rear-end crashes resulted in 1,705 fatalities and represented almost half of all 2-vehicle fatal crashes. This 2015 study is the basis for a majority of our currently open safety recommendations. Since 1995, collision avoidance technologies have often been a focus of our most wanted list, and in fact is on our current 2019-2020 list. That's the reason we're conducting this webinar today. We found that in our 2015 study, collision avoidance systems could have prevented 1,700 fatal rear-end collisions annually. Our investigator, Dr. Insar Becik, will discuss recent crashes where collision avoidance systems could have made a difference, such as San Jose, California. Field testing of forward collision warning technology in a large truck fleet has been very promising. These systems have resulted in lower crash rate, as well as a decrease in risky behavior by drivers of these vehicles. In June 2016, NHTSA published a special study entitled Field Study of Heavy Vehicle Crash Avoidance Systems, which sampled 6,000 crash avoidance system activations over 3 million miles and 111,000 hours of naturalistic data. None of the systems activated were associated with collisions, nor did companies report any rear-end collisions involving the vehicles in this study. The 2015 study by University of Michigan Transportation Research Institute found that in the large motor carriers they surveyed, forward collision warning reduced crashes by 14%, blind spot detection by 5%, and vehicle communication systems by 9%. But what do we want? Many of our recommendations have gone to NHTSA, asking it to develop and apply performance standards and protocols for the assessment of forward collision avoidance systems in commercial vehicles. However, despite the studies showing benefits, NHTSA still does not require manufacturers to install forward collision warning systems, even as the European Union has moved to require AEB on heavy trucks. In June 2015, the agency mandated electronic stability control, ESC, for new Class 7 and 8 tractors by 2017, estimating that electronic stability control would prevent more than 1,700 crashes. However, it did not require that ESC be paired with other collision avoidance systems for maximum benefit. In 2015, we made recommendations H15-8 and -9 to industry to voluntarily incorporate advancements. We're asking truck, tractor, motor coach, and single-unit truck manufacturers to install forward collision avoidance systems as standard equipment on all new vehicles. Finally, these systems require training. Drivers need to understand what these do and not do. Collision avoidance systems help them drive more safely. They do not drive the vehicle. A recent passenger vehicle survey conducted by the AAA Foundation for Traffic Safety found that 40% of drivers didn't understand the limitations of FCW and AEB or confused the two technologies. Operators need to train drivers regarding these technologies. Today we'll hear from one operator regarding how his company trained drivers. By the way, we've issued a safety alert regarding the importance of consumer awareness and adoption, which is included in the documents section of this webinar. So what's our progress to date? Passenger vehicle manufacturers are making headway incorporating these technologies. However, implementation in commercial vehicles is much slower. According to our analysis of Consumer Reports data, 32% of new 2018 and 19 passenger vehicles offer collision warning systems as standard equipment. Another 63% offer it as optional. By comparison, in 2016, only 14 to 15% of new Class 8 tractors in the U.S. were equipped with collision mitigation systems, although that's up from 7% in 2013. Passenger vehicle manufacturers agreed with NHTSA and IIHS, the Insurance Institute for Highway Safety, to include AEB by 2022. A recent update found that 10 automakers reported equipping more than 50% of the vehicles they produce during the year starting September 1, 2017, with automatic emergency braking. The top 4 OEMs managed to equip 90% or more with crash avoidance technology. A similar agreement by commercial vehicle manufacturers would be a welcome counterpoint. Larger operators such as UPS and Walmart have made tremendous strides in this area. We'll hear from a smaller operator today. Let me be clear, this webinar is not a discussion about autonomous vehicles or what some call driverless vehicles. Collision avoidance systems are the building blocks of automated vehicle systems. However, those vehicles have additional sensors that allow improved obstacle detection and recognition. Some closing thoughts. Collision avoidance systems won't prevent all crashes, but they can prevent a substantial portion of them. Also important is the potential for this technology to mitigate crash severity, which can mean a difference between a fatality and a survivable injury. Technology is advancing, and future generation systems will be even more capable of preventing more types of crashes. One of our presenters today will talk about his perception of the evolution of the technology. While more OEMs are making this equipment standard in their trucks, most still await requests from operators to fit them as needed. That's why we implore you to ask for them. We also strongly advocate for educating all drivers on how collision avoidance systems work. Ultimately, the safety benefits and positive impact on retention and ROI far outweigh the advantages. We encourage you to listen, learn, and make use of these systems now.
Well, thank you, Member Weener. Appreciate those opening remarks. Now I'd like to turn it over to Insar Becik, an NTSB highway safety investigator, who will discuss 2 crash investigations in which these technologies could have made a difference.
Thank you, Amy. Member Weener has given us a great overview of the importance of the collision avoidance systems and also of the long-standing advocacy that the NTSB has done with primarily forward collision avoidance systems in the highway mode. So before our panelists talk about how and more importantly why they are bringing various collision avoidance systems into their fleets, I will very briefly present a couple of crashes that the NTSB has investigated in which a forward collision avoidance system could have had an impact on the outcome. So one of the crashes that we examined in the 2015 Special Investigation report that Member Weener discussed just now occurred in Cranbury, New Jersey. The crash actually occurred a year before. And since this SIR, we've investigated several other crashes involving commercial vehicles, and I will discuss one that occurred in San Jose, California in 2016. So first, briefly about Cranbury. Although this crash occurred late night, just before 1 a.m., there was considerable traffic on Interstate 95, which, due to the reduced speed limit, which was 45 miles per hour at that location, due to the approaching road construction, the traffic has slowed. And a 2012 limo van, it was a Daimler Sprinter van, was approaching the end of that traffic queue, and it had slowed to below 10 miles per hour. At that time, a 2011 Peterbilt truck operated by Walmart and driven by a fatigued driver was approaching this location, and while traveling at 65 miles per hour, struck the limo, which then was pushed and collided into other vehicles. And the Walmart truck continued and struck another vehicle. The images on the right of the slide show the rest position damage to the truck tractor, and this second image shows the scanned image of the damage to the limousine. So as a result of the crash, the one passenger of the limo had died, and the driver of the limo and 5 other passengers, limo passengers, and 3 occupants of other vehicles sustained minor to serious injuries. So this truck was actually equipped with a forward collision avoidance system. So we will go into this next. So this was as I said, 2011 Peterbilt truck, which was equipped with Bendix's Wingman ACB system. This system had adaptive cruise control, which provided limited throttle deceleration and had forward collision warning with capabilities to detect certain even stationary objects and to provide visual and auditory alert to a driver. However, the system did not have automatic emergency braking system. So the Analysis of the Bendix's wingman showed that at the time of the crash, the driver did not use the adaptive cruise control, which means there was no automatic throttle reduction. And additionally, the data showed that the system did not provide a warning, forward collision warning to the driver. However, we could not conclusively determine that a warning did not happen. It is feasible that a short warning of a duration of less than half a second did occur. But that brought us to issue with the data of the systems of this generation, which is how the data is recorded, at which frequency, what kind of data and variables are recorded, and how can it be retrieved. So that is the kind of recommendations that we made to the CAS manufacturers, to Bendix and Meritor Webco. And the second recommendation that we made in this crash was actually a reiteration to NHTSA, and it's one of the recommendations that member Weener has just discussed. And that is for NHTSA to really hurry up and to develop the standards for forward collision warning systems for the application in commercial vehicles. One important aspect in this crash is it involved a very high velocity differential. Truck tractor traveling 65 miles per hour coming up on almost stopped traffic. So the next crash I want to briefly discuss occurred in San Jose in January of 2016. And this involved a Greyhound motor coach that was traveling northbound on US 101 in a late hours at about 6:30 a.m. So which means there was considerable commute traffic, but it was still night conditions with moderate to heavy rain and with wind gusts. This is a screen capture of a drive camera that showed just the conditions on the road at the time of the crash. So as the driver of the Greyhound motor coach was actually intending to take an HOV exit lane, but instead of taking the exit lane, the driver traveled in or entered and traveled in a gore area, which, as these images show, was unmarked, meaning that they did not have chevrons to indicate an untraveled lane. And as you can see, the gore area was as wide as neighboring travel lanes. So at the end of the gore was a crash attenuator in front of a concrete barrier. This crash attenuator was damaged previously, almost a month before, and the retroreflective sheeting that would have been present in the front, on the front barrel, was missing. And also one of the Type 1 barriers was absent from that location. This image shows is a screen capture of the drive cam again, right moment before the impact, and the yellow arrow points to the location of this barrel. As you can see, the black barrel surrounded by dark conditions and flashing lights and lights of other vehicles indicates the kind of conditions that the driver was facing. And because of the drive cam and the driver facing drive cam, we were able to discount driver's distraction, who until the very last moment did not realize was traveling in a gore area and was approaching a hazard. So as a result of the crash, 2 passengers of the Greyhound motor coach have died and 13 other passengers and the driver sustained injuries. This motor coach, this was a 2014 NCI motor coach and was not equipped with any collision avoidance systems. And like in the Cranbury, this involved a high speed of travel, 56 miles per hour, and in this case was encountering a stationary object, not a vehicle, but nonetheless a stationary object. So we were interested in whether a collision avoidance system had the capability to detect such hazards, this type of a stationary object. So we conducted testing at the Transportation Research Center in Ohio, And because Meritor Webco was the provider of the collision avoidance systems for certain Greyhound buses, we worked with Meritor to test their on-guard system, which was installed on a truck tractor due to availability, and tested to see whether it would have been able to detect a crash attenuator, a barrel. So this collision avoidance system, the on-guard, consisted of both collision warning and automatic emergency braking. So we ran several conditions at different speeds, up to 55 miles per hour, in which the truck tractor was approaching a barrel with or without retroreflective sheeting. The test findings showed that the system was able to detect the crash barrel, the attenuator, in almost all of the trials, and the system provided a visual and auditory warning to the driver, as well as engaged automatic emergency braking. The collision warning was provided within the range of between 2 and 2.5 seconds, and the automatic braking was engaged between 1 and 1.5 seconds time to contact. As soon as the automatic braking began, the driver steered away, which disengaged the automatic emergency braking. As a result of this crash, we've made reiterations that member Weener has discussed earlier. Again, one was to NHTSA to, as soon as possible, develop the standards for forward collision avoidance systems in commercial vehicles, and secondarily to the manufacturers of commercial vehicles, heavy trucks and motor coaches, to install collision warning systems and automatic emergency braking as standard equipment in their vehicles. And this was a brief discussion of the crashes that we have seen. And next, we'll have several presenters who will discuss why they are installing these systems into their fleets.
Okay,
Amy.
Great. Thank you, Ensar. Now we want to, first I want to remind folks that they can put in questions or comments to the right in the questions section, so feel free to do that as you go along, and as I said, we will try to address as many of them as we can at the end. So now I'd like to hear from Ross Froat, the Director of Engineering and Information Technology at the American Trucking Association. Ross will provide an overview of industry implementation and adoption rates. And again, thanks to Ross and the ATA for working with us on this event. So, Ross, I turn it over to you.
Awesome. Amy, can you hear me?
Yes.
Great. Thank you very much, NTSB, for having me on and having ATA part of this discussion. Today, like Amy said, I'll give you an overview of some industry implementation and adoption metrics, things like that. On this slide, I'll just introduce myself again. I'm Director of Engineering and Information Technology. I oversee ATA's Technology and Engineering Policy Committee, our Automated Truck Subcommittee of that policy committee, our Technical Advisory Group, and I have many roles in ATA's Technology and Maintenance Council, all of which I handle pretty much everything bumper to bumper on any commercial piece of equipment that ATA represents, and a lot of communication, cybersecurity issues, off-board, on-board things, and so forth. So that's all under my office, and I'll describe a little bit more ATA. Next slide, please. So ATA is a very large organization. They are a federation of councils and conferences and their own membership and affiliated associations and trade groups. What you see is just a list of everything that we cover, all different sectors within the trucking industry, a lot of different councils that represent a lot of different areas within type of motor carriers. The membership of ATA is majority fleets, and then technology suppliers, truck manufacturers, business providers, and academic affiliations. Just to let everybody know, ATA represents all 50 state trucking associations under the Federation umbrella. And so it's a very, very large membership and a lot of different aspects involved. And the technical expertise of many of that falls within the policy committees that I manage. Next slide. I want to point out our annual meetings because I won't name out everything that you see here, but I do want to recognize that collision avoidance systems, advanced driver assistance systems, and every other term that it may be called in the future, we do plan around these things. And our sessions at our meetings focus on fleets adopting these technologies, how they're applying it through their drivers, through their equipment, in so many different ways. So there's a lot of things that ATA does for safety technologies on truck equipment. And we do that by bringing a lot of attendees in. These meetings get around 15,000 attendees a year annually on a lot of different types of sessions. And we definitely focus on vehicle safety technology. And that's pretty much almost it about that. Next slide. NTSB board member Weener hit it on the nail. Couldn't have explained it better. Currently driver assist, not driverless. We are extremely focused on the driver workforce and training the driver through the safety technologies that we are currently at and going towards. What you see here is just a number of our captains in the past for ATA. If you don't know, we do have a huge image campaign and a lot of safety and driver training type of developments between each of these captains that represent their fleets and also drive around trucks throughout the nation, working with other drivers and fleets and the public, and focusing on a better driving environment. And a lot of this is from these captains, and I want to focus on that too. So next slide. So what you see in front of you is, are just like what board member Weener expressed, building blocks to automated truck technologies. We talk a lot about AEB. A lot of this focus of this session is on AEB. What you may not know is what's underneath there is DBS and CIB. That's dynamic braking support and also crash imminent braking. Those are really the two technologies that support AEB in a lot of different ways. That is when you're hitting your brake, thinking that you're slowing down enough, the system can actually press on that brake, increase the braking of that technology, thinking that you're not pressing the brake hard enough. There's just a lot of different types of algorithms and communications going on in between the system and the driver between AEB. And it's good to know that what is happening when you're actually applying AEB on your vehicle. And then I won't get into all these, but active electric steering, AES in the red block, is really currently expanding and developing very well in trucking. And just to know that lane keeping assist, lane departure warning, things like that are also collision avoidance systems and advanced driver assistance systems we want to keep focusing on. Next slide. Two new technologies I definitely wanted to share. If you haven't seen the DOT notices on any of these, camera monitoring systems for replacing your exterior mirrors on a truck with cameras is now legal through a certain manufacturer device. You may have already seen, but will see maybe in the future, a truck driving by you with no mirrors on the sides of the tractors. And these devices are considered driver assist safety technologies and collision avoidance. Seeing in the night vision, blind spot maneuvering, panning with the trailer tail. There's a lot of things that this technology alone can avoid accidents with. Adaptive driving beams is another. NHTSA just passed passed a request for comment on this notice, making it an option for installing an enhanced forward lighting feature on cars and trucks. Does not limit to anything, on making a beam of light focusing on vulnerable road users on the road, and also lessening the glare of passing and incoming traffic. You may see it all the time, like I do when I drive at night, of how these headlights irritate your sight while driving forward, seeing the lights that come back and forth. This is the optional safety enhanced equipment that Europe has been using for a long time. and U.S. is now at least having a comment period of seeing if they should change the FMCSS standard on this. Next slide. And I won't even get into all this, but just let everybody else know there's a lot more out there. And a lot of it prevents collisions. Everything you see prevents a collision. One example, the tire picture I have there, that is an automatic tire inflation system. Every driver out there may see some sort of tire pieces on the road. That's usually due to irregular wear and underinflated tires. These systems prevent those tires from causing damage or causing an accident or some sort of way out on the roads. The collision avoidance system, there's a lot of definition between a lot of these things. And then the picture right next to that is vehicle to vehicle to vehicle to infrastructure. There's a lot of communication technologies out there that are developing, testing, and ready to be deployed. We won't get into those since it's an AEB discussion, but I just want to let everybody know these things are happening and coming. Next slide. ATA supports AEB for all vehicles. This is our policy that we passed in 2015. We support a DOT voluntary program challenging vehicle manufacturers to standardize AEB on new vehicles. As previously mentioned, there are a lot of truck OEMs that are announcing a standard feature for AEB. And we also support a fleet incentive-based program to expedite ADAS technology adoption. We meet with FMCSA and DOT, other DOT agencies on this multiple times, and we are constantly focused on how we can advance the adoption of types of technologies through an incentive-based program. Next slide. So last year in 2018, this time actually, internally of ATA, we kind of did a little informal survey with a core group of our motor carrier members. This core group of members represents nearly 500,000 power units. And we did a little survey. We did a lot, but I did want to focus on these things just to let everybody know what a very large percentage of the heavy truck equipment that you see on the road is doing. And in 2013, they had 17% of their entire fleets amongst these 30 carriers, or average 30 carriers, using collision avoidance systems. In 2017, the year before we took this survey, it was up to 42%. And then last year, predicting what this year would be for them, they were expected to have 62% use of collision avoidance systems. Now, it was very broad of how we did this survey, but majority of the questions focus on AEB and adaptive cruise control. Many other types, but minority of those percentages were on blind spot detection, forward collision warning, and lane departure warning. Next slide. The last thought I just want to say is that technology choices will depend on business operations. What you see in front of you are just three sectors of the trucking industry. There are plenty of other types of sectors: disc brakes versus drum brakes, AEB versus just forward collision warning. There's a lot of different choices out there for a lot of different safety technologies. Some fleets may utilize them better than others, but we definitely want to keep focused on what is best for the organization as a business decision for making their trucks safe. And we stand by that. Next slide. And that concludes my presentation.
Okay, well, very interesting stuff there. I like to see those numbers. So thank you, Ross. I appreciate it. Now I'd like to turn it over to two trucking company reps who will discuss how and why they decided to incorporate advanced safety tech into their truck fleets. We will begin with Todd Porter here for the Vice President of Safety for Sentinel Transportation, LLC. Sentinel is a Texas-based carrier that includes 400-plus hazmat carrying tanker trucks operating out of 30 terminals across the country. Todd, all yours.
Thank you, Amy, and thank you for inviting us to participate today. If you go to the next slide, you'll see that Sentinel Transportation, we've been committed to various advanced safety technologies since 2004. Back in 2004, we started looking at forward collision warning and started to adopt, and throughout the years we've consistently added technologies, updated our braking systems, updated video telematics, lane departure warning, all of those kinds of things. So we have been very committed. Part of what we've done for our entire life as a company is hazmat and high hazard chemicals. So for us, safely delivering those products was absolutely mission critical to the organization's culture, protecting our drivers as well as protecting the public from any types of incidents. So we've looked at this technology as an opportunity for us, provided that we understood the technology and made sure we used technology properly, to really be able to manage our safety and manage our fleet very effectively. By the end of 2018, 88% of Sentinel fleet had some or all, and most of our trucks had all of the technologies in the vehicle. Part of the reason we don't have 100% right now is because we have some specialty equipment where some of these technologies isn't appropriate. They're low speed, they're off-road, they're not out on major roadways. So the use of the equipment is not appropriate for those kinds of situations. I will tell you, we did a quick analysis, and we're in the process of updating this, but we have the analysis from 2014 through 2016, and what we found, and this wasn't the primary reason for doing it. The primary reason was to reduce accidents and injuries. But one of the things we did find is that our per year claim cost as a percent of revenue decreased by 90% from 2014 to 2016 as compared to the per year average for the 10 years prior. So 2014 is when we found that we'd kind of hit the critical mass. We'd gotten quite a significant level of use in our vehicles. So we started to really look at what was the impact of that technology that we put in, and it was huge. Our DOT accident frequency per million miles also went down by 14%. Our DOT accident frequency as a whole is actually very, very low. So an additional 14% is a good number. As of 2019, that'll be our first full set of vehicles that are coming in with automatic emergency braking technology included with our other suite of safety technologies. So we're pretty excited about that. We think that that's really the next big opportunity in truck safety. We feel like the automatic emergency braking is finally kind of gotten to the point where it's proven well enough that we feel comfortable that it will produce the results that we're looking for. So we're very excited to see our 2019 fleet come in. We can go to the next slide now, Amy. So as I go around and I speak to groups about technology and about safety culture and process, one of the things I always try to remind from our learnings as an organization is that, technology is good, okay? Technology works. However, there's things that need to happen in the background to make sure that technology works effectively, works properly, and works the way we want it to be. So first, we need to understand technology, what it can do and can't do. So, for example, forward collision warning versus forward collision avoidance. Now, typically we say forward collision avoidance, we're talking about including some sort of automatic emergency braking component to it. So understand what the difference of those are, because they're going to work very differently in your truck. We need to properly implement that technology. So developing and implementing the support systems, the training, the policies, the procedures, all of those things that go with it. You don't just put the technology in and hope that it works. The technology interacts with human beings. Those human beings need to understand how that technology is going to impact them, how it's going to impact the way they operate their truck, and how they need to work with the technology to get the most benefit out of that technology, as opposed to fighting the technology and reducing the benefit from the technology. Lastly, if you're not going to use the technology, don't put it in, because what you're doing is you're either creating a friction with the driver because they don't understand why the truck's not working the way they think it should be, and or you're creating other risks by putting something in that isn't being properly implemented and properly used. One of the things I always try to remind folks is technology is a tool. It's a tool by which we can drive behavior change. And it's the behavior change and the interaction between the human beings and the technology that gets us the most value. And that's what we need to focus on, is how do we use technology to train our drivers to be better drivers and to use the technology in a way that gets the most safety. So we can go to the next slide. So if you're out there thinking, okay, well, how do we do an ROI? I would tell you it's a big challenge, because you don't know what you don't know, and you don't know. It's hard to measure what incidents you avoided by having technology that's going to help you eliminate those. So ROI may not be your best. You should try to do it, and you should try to determine if there's numbers out there that can help you sell the financial value of it. But it's about the cultural. It's about teaching employees. It's about caring about the public and caring about your employees. How do you measure the value of something that doesn't happen? Okay. There's also compliance improvements. You get a lot of great compliance improvements through putting these technologies and raising the bar in your safety culture. Okay. One of the things that people tend to forget about is, what's your reputational risk worth? So if you have that bad accident, and I hate to point it out, but for example, the publicity out of the Walmart accident that occurred, how much is that worth to you? And there's an intangible value there that we all have to understand. Saving lives is not always about the financial improvement. It's about helping to save lives on our roadways. So I'd just like to remind everybody about that. It's important to remember that, doing an ROI, if you can do it, it is valuable. But think about all the other safety benefits you're creating through use of these technologies. The good news for us as an industry is that the cost of technologies are coming down. They're starting to be implemented with the manufacturers. So that exorbitant price ticket is coming down to a point where many of us can continue to use these technologies without the huge financial burden that it was 3, 4, 5, 10 years ago. We can go to the next slide, Amy. So training employees. This is critical to the success. We learned the hard way that if you don't train your employees, then you create stress and anxiety that doesn't necessarily need to be there. So make sure your drivers understand how the technology works. Understand the benefits and limitations of the technology. Okay? Understand the impact on their driving behaviors. How do they drive? And one good example of that is when our braking systems improved, we went from having to stab the brakes to constant pressure on our brakes. Okay? And so it's critical that they understand those details so they understand how to drive that truck in a way that works with the technology. They should understand the benefits of the technology. Okay? What happens when it activates. They should be fully prepared that when that vehicle starts braking on its own, they're prepared that it's happening for a reason. Something's going on, whether they recognized it or not, whether they were distracted or not. The truck recognized the need to brake, and therefore that's why it's happening. If they're properly trained, they can appropriately react, they can ensure the highest value out of the technology, and they can avoid overreacting to the technology. And I think that that's really important to the success of the advanced safety systems. And we go to the next slide. So, talk about financial impact of exceptional safety. And again, this is not something we were necessarily looking for. It wasn't something, we bought into the technology because we knew it was the right thing to do. We believed that we would see an overall financial impact, but we weren't, that wasn't our most important element of our commitment. However, if you look at the industry as an average, you'll see anywhere from 4 to 6% of revenue for a good, solid company who's doing a good job in the trucking industry. So if you look at that as $100 million in revenue, you're looking at $4 to $6 million in insurance and risk cost associated on an annual basis for an average trucking company. Sentinel, and this is our long-term 10-year average, is 0.5% of revenue. So you're looking at a $500,000 per year cost of risk as opposed to a $4 to $6 million cost of risk. And so, you know, it is a huge financial benefit. First couple of years, you may not see that impact, okay? However, as your culture changes, and again, I want to bring everybody back to culture, systems, and processes have to work together. And if you have the systems, the advanced safety systems, without the culture and without the processes to support them, you aren't going to see these kinds of improvements. You're not going to see the benefit that you're looking for. So you need to make sure that you've got all of the support systems in place to make sure that technology is going to work properly. So the potential impact, financial impact, can be huge. Now, I'm not saying everybody's going to see these kinds of numbers, but I know that they've worked for Sentinel. We've been able to prove the value of the technology multiple times over. So thank you very much, Amy, for having us. That concludes my comments.
Okay, great. Thanks, Todd, for that insight into what your company is doing there. Now, let's hear from a smaller operator, Sentinel Transportation. Robert Haig is the Vice President of Operations for Sentinel, which is an Indiana-based family-run operation that includes about 30 tractors, 55 trailers, employing about 20 drivers. It provides long-haul regional distribution from coast to coast. Robert?
Hi, Amy. Thank you. And thank you to the NTSB for the opportunity to speak and participate in this webinar today. We also echo Todd's comments as well for the greater, wider industry. So I'll try not to be repetitive, but I want to thank Todd for his comments and phrasing some of the larger fleets' returns sort of in a different perspective as the smaller fleets. So next slide.
Robert, this is Amy. Sorry.
Yes.
I meant to say Robert Haig. I'm sorry. Is from Perfect Transportation. So I combined my thoughts.
No problem.
Perfect Transportation. Wrong company there. Robert, go on. Next slide.
Great. So we have sort of the perfect theme. Perfect Transportation operates as a subsidiary to Perfect Pallets. We operate a plastic pallet company that provides plastic pallets to the newsprint and print advertising industry. So we have a trucking division underneath that Perfect Pallets brand, and that's Perfect Transportation. And we also have a manufacturing division called Perfect Manufacturing, where we manufacture those plastic pallets. We are a third-generation family business. Like Amy said, we operate with 30 tractors, 55 trailers. We have national coverage from coast to coast. Our headquarters is here in Indianapolis. We've got a terminal down in Dixon, Tennessee, and a terminal out in Chandler, Arizona. And we also have a few trucks that travel and primarily stay up in the Northeast. So we've got a lot of exposure coast to coast with these technologies. Next slide. So we consider ourselves to have quite a robust and positive safety culture at our organization. We've been early adopters of a lot of technologies that we feel enhance that safety culture. And that's why we were one of the early adopters, we feel, to the electronic logging devices that became mandated just within the last year. We first put those devices in our trucks back in 2004. And with putting those devices in our trucks, we were able to get hours of service alerts on driving and on duty time. We also got alerts on speed alerts of our tractors that may be speeding, so we could contact those drivers and make sure that they kept that under control or at least found out what conditions caused that. And also got some hard braking events where we were able to contact the driver and find out if there were adverse weather conditions or traffic situations that may have caused that could help to enhance training in the future. So in 2014, we've decided to put camera systems into our tractors in our full fleet. Those were both forward, outward-facing cameras and also inward-facing cameras to monitor what was happening outside of the truck, in front of the truck, but also in the cab at the same time. And quickly after we installed those, we figured out that there were some driver distraction behaviors that were taking place and saw some of the conditions on the road. Because of that, we quickly instituted an absolute no cell phone policy within our company in 2015, and we've been adhering to that ever since. I know hands-free Bluetooth seems to be the go-to out there for a lot of drivers to pass the boredom. We at our company have just found that can continue to contribute to distractions and have worked to eliminate those sort of things. We also do mandatory monthly training with our drivers, video training, for them to stay up to date with the latest, not only maintenance skills, but safety skills. Next slide. So in 2014 as well, we decided to take the leap and add some active cruise control with forward-looking radar to our new set of tractors at that point. And it was interesting in 2014 to 2015, using some of that camera technology, we were able to identify the benefits of that technology. We were able to visually see what was taking place with the tractor and the driver. And that's why between 2015 and 2020 model tractors, we have gone full speed ahead with active cruise and also adding emergency braking to those tractors as well. We proactively phased out our older equipment that didn't have some of these safety devices and phased in newer, safer equipment. And because of that, today, our fleet is 70% equipped with some type of forward advanced collision alert system, either active or passive. And why did we do this? We did it because we wanted to continue that safety culture. We felt like we wanted to be on the front end of things rather than on the rear end of things as far as technology phase-in is concerned. The camera systems within our trucks really verified the way in which these forward collision systems were working and collision mitigation systems were working, really gave us the confidence to continue to invest in the technology and know that it was the right thing to do. We also think that these are the future building blocks to automated trucks in the future. During the introduction, I think we did a great job of laying out, what the technology is and what it's not. We feel like these systems are the future, or what the future will be built upon. So we want our drivers and our fleet to have some exposure to those technologies now, instead of just being confronted with them in the future. Next slide. So here's some thoughts. Some of the pros. If you have a U.S. DOT number out there, it is your requirement to put safe equipment on the road. The DOT expects that, FMCSA expects that, and the DOT is going to verify and make sure you've got safe equipment on the road. So we feel like we're putting safe equipment on the road by investing in these technologies. And we also think that it's vital for small business to survive. For us, it doesn't take much to end up on the wrong side of an accident that could severely hamper the current operation and future operation of our organization. So we want to make sure that we survive well into the future and do what we can to do that. And recruiting and retention, these brand new tractors equipped with the latest bells and whistles, we like to use that as a reward for our drivers, driver appreciation, to make sure that they're proud of the equipment that they have on the road and are sort of respected by their peers and look good, look sharp going down the road, new, clean, and comfortable. Next slide. So some of the cons. Well, back to recruiting and retention, there is a driver learning curve in the training of what these systems do and what they don't do. I think Todd did a great job talking about that, pointing out that drivers are a big part of this. It takes some adjustment on their driving skills to be able to figure out, how the systems work and adapt to distance between vehicles, how to recognize the alerts. And because of the alerts, it takes some adjustment too to be able to figure out what those buzzers and sounds mean when they go off. What is a small, beep, beep, beep versus a long, solid beep, and make sure that those drivers don't have beep fatigue, if you will. And maintenance can be an issue as well. You see a lot of on-road fault alerts that can happen. That might be due to debris covering up the sensors. A sensor might get knocked by a piece of debris. It might be kind of off axis and may need to be recalibrated. It can knock some of those radar systems off too. You have to make sure that those are still in working order every time you bring the tractor in for preventative maintenance. And because of that, you have to educate your shop and educate your maintenance professionals to be able to recognize these new technologies, get them up to speed on the newest computer programs that are used to calibrate these technologies, and make sure that every time the truck does touch your shop, you're giving these systems the attention they deserve, just like the oil change and the tires and the air conditioner, et cetera, et cetera. So these technologies do come with a cost. They are added cost when you put them on from the dealer perspective. And, they also have a human cost. It does, they say time is money, and it certainly costs you to make sure that you're investing in the training and invest in the education for everybody in your organization to consider how these systems work. Next slide. So some final thoughts with ROI. We think we're taking a proactive step in investing in safety for our fleet and for the motoring public. But for us as a small fleet, it really is hard for us to define that return on investment. Like Todd said, if we didn't have a catastrophic accident before we put these systems in, and then we haven't had one since after putting these systems in, we really can't say that one was correlated to the other, or it was because we put these systems in that makes us a safer fleet. We hope it makes us a safer fleet, but we're also employing the drivers that we hope are being safe out on the road as well. So, a business hypothetical: investment on the front end can be extremely minimal in proportion to what could be at risk on the back end. Going back to Todd's comments, that the investment on the front end is something that could be taxing on your financial statements, but it could be catastrophic if something happened because you didn't take that proactive step to begin with. And as a business owner or executive, what keeps you up at night? I'm sure it's the idea of having that catastrophic accident or fatality, and we hope that this technology can somewhat mitigate that and help us get a little bit more sleep at night. So that concludes my comments. Thank you, Amy.
Thank you, Robert. Again, also a very interesting perspective from the smaller operator. We are run right up against 3 o'clock for all of our formal presentations, and I wanted to kick off some questions with a question that I have for myself that I would like to hear more about the driver's perspective. Before I get into that, I just want to mention that after that, I do have several questions from the audience that we will get to. So if you can hang on for another 10 or so minutes, we'll try to get to as many as we can. But going back to a question, I've asked someone to join us on the phone here from the Teamsters Union. Her name is Miss Angélie DeGrasse. She's the Deputy Director of the IBT Safety and Health Department at Teamsters. And I thought, we've been hearing from fleet operators and, NTSB's perspective, but I wanted to know a little bit more about what the ones sitting in the seats, the drivers, are thinking about these technologies that are increasingly coming on their vehicles. So, Angélie, maybe you can give us a little insight into what you're hearing and from drivers and how they're responding to the increasing incorporation of this tech in the vehicles.
Yes, thank you so much. I'd first like to thank NTSB for inviting us to speak. I'd also like to thank the driving population of the International Brotherhood of Teamsters and my colleagues at the Amalgamated Transit Union for providing valued feedback on the collision avoidance systems and the driver experience. The International Brotherhood of Teamsters represents about 1.4 million workers in many different trades, the majority of which consist of commercial motor vehicle drivers that work in a variety of sectors, including LTL, freight, parcel, express delivery, passenger transport, rail, port, and solid waste and tank haul, etc. So safety performance technology, like collision avoidance systems, could be an invaluable tool for the professional driver as long as it is designed with the professional driver in mind. In general, the feedback I receive regarding what we call SAE Level 1 driver assist automated technology is positive regarding its performance in ideal, and I stress ideal, road conditions. However, the current concern of our drivers is that the collision avoidance braking technology currently employed in many of the CMVs they drive can create a very serious situation that has the potential to contribute to rear-end collisions, jackknife-type situations, or contribute to driver distraction due to unnecessary brake deployment and repeated false alerts. Regarding the driver experience with collision avoidance system technology, folks should keep in mind that CMV drivers operate in dynamic driving conditions, including rain, snow, wind, fog, traffic congestion, driving through tunnels, under bridges, under directional signs, and through road construction zones. The operational design domain of the collision avoidance systems our members are most familiar with is not necessarily designed to operate or does not perform optimally in many of these naturalistic driving conditions. Further, this system does not work for vehicles approaching from the side or in oncoming traffic. Thus, a number of the comments I receive regarding the driving experience have not been overwhelmingly positive, but drivers do believe this technology is a start. Further, due to some technology limitations described in the user manuals, even during proper use in ideal driving conditions, like steady state traffic flow during bright sunny days, the technology may provide false alerts, which result in engine retardation and subsequent application of the foundation brakes. According to a number of our Teamster drivers, the number of false alerts drivers receive on a daily basis can be overwhelming, which results in a culture of mistrust in the technology and unwillingness to use it or rely on it even when the system is operating in its ideal design domain, thus contributing to a negative user experience. The most frequent complaint we receive regarding the collision avoidance system is that it unnecessarily engages while driving under bridges, under or near large road or directional signs, when road curvature changes and sensor misbehavior falsely alerts drivers to other vehicles that are in adjacent lanes, maybe 1 or 2 times removed, and in areas where road infrastructure is not well maintained or line markings are not clearly defined. Another frequent complaint from drivers, especially those in passenger transport, is the sound level of the alerting system and the inability of the driver to adjust the volume in factory-installed units. Regarding the alerting system, note that drivers of passenger transport vehicles have been subject to harassment from passengers who complain about the noise or who might automatically assume the driver is not operating the vehicle safely because of the sheer number of alert sounds heard, leading to driver harassment. Additionally, passenger transport drivers report that driver monitoring cameras, as currently designed or placed, do lead to severe driver distraction. So it's important that our OEMs, in developing safety performance technology, ensure that the technology itself does not introduce additional or unintentional safety hazards by its use. Now, our drivers did have a few improvements they'd like to share. While it is advised in the user manuals not to use adaptive cruise control with braking and inclement weather, most drivers do and are instructed by their employers to use the system regardless of weather conditions. This leads me to my point on training, which a number of our previous presenters have mentioned. Employers and drivers alike need proper training on technology use, limitations, maintenance, and troubleshooting of both the hardware and software components. Drivers must have the opportunity to review printed materials, ask clarifying questions, and receive hands-on and/or simulated instruction prior to implementation of the technology. Additionally, even in inclement weather, the alerting systems are always engaged and relying upon proper functioning sensors, cameras, and our radar. Per the user manual of these systems, driver is instructed to clean off snow, mud, and ice from the sensors so they work properly. This is unrealistic and unsafe for drivers of property-carrying CMVs and for drivers of passenger-carrying motor vehicles while the vehicle is in transit. Bottom line, our drivers want the technology to function in all of its naturalistic driving conditions, period. Drivers would also like the ability to adjust the volume of the alerting system, which is always engaged, and in congested road conditions can lead to workplace stress and distraction for the driver due to the continuous beeping, buzzing, or vibrating alerts to situations that are typical of road congestion but are not indicative of a hazard or worthy of repetitive driver alert. This is especially a problem among our team drivers, as the alerts disturb the sleep of the resting driver. Drivers would also like standardization to the common alerting system to assist drivers of mixed fleets so the operation of the system is inherent no matter the vehicle manufacturer. Improving on sensor technology to minimize the amount of false alerts would help drivers receive, which contributes to help drivers minimizing the amount of false alerts drivers receive will help drivers not to be subject to alarm fatigue and mistrust of the system. Lastly, safety equipment and technology should always be designed with the user in mind. In this case, fit the equipment or job to the worker, not the other way around. We want to enhance the professional skills of the drivers that they already have. Most drivers are excited about new technology designed to provide them with real benefits and increase safety performance, and drivers are generally willing to try out new technology. OEMs, however, should do their part and extensively involve drivers at the initial development phase that will help them really understand driver concerns, gain insight from drivers on what features would be most helpful to them in increasing safety performance. This initial involvement, in turn, would naturally have a positive effect on future driver acceptance.
Okay. Ajale, wow. Very, very thorough answer there. Hopefully the people on our line got some good advice and information, because you tapped into what my next question was going to be about tips and pointers, and you covered a lot of those. So I appreciate that. I just wanted to mention there's been a lot of questions about will the slides be available. I'm saying that we have this webinar is being recorded, so we will make the recording available. We have to look into whether how we would process the slides for the attendees, but I have all the registrants, so I will get that information to you. But the recording will definitely be available within a couple of days. Anjali, you mentioned you talked extensively about false alerts being a concern, so I want to throw out that question to address that for our panel. But I guess I'll begin with INSAR here on our team. In the past, false alerts were an issue, but how much of an issue are false alerts with the newer systems that you're seeing or hearing about? And what are your thoughts on CA-CAS that only alert drivers versus those that act on the vehicle and brakes and wheels? Do you recommend one over the other? It several of them all kind of go together. Some of these questions about rear-end collisions still occur with vehicles that are equipped even with the latest forward collision warning and AEB, especially when there's high closing speed. What are some challenges that exist to reaching the point of eliminating these crashes? I know it's many questions all at once, but if you can address some of these aspects in terms of false alerts and what you're seeing on the vehicles in today's technology.
Okay, I will do my best to attempt to answer all 17 of those questions. But Amy is correct that they do describe a large, really area in terms of effectiveness and how good are they today versus how good can they be, especially when comparing it to what people generally think that they can accomplish. But the one question that I think someone asked does deal with high velocity differential, especially with commercial vehicles, with truck drivers driving on highway at highway speed, 65 miles per hour, encountering stopped traffic. That really is the most challenging situation in which they can find themselves, and it's the most challenging situation for these systems to be able to detect and to alert the driver in time for them to respond or to activate emergency braking. So how do we get there? And the answer is it's really a gradual process compared to where we started in mid-90s, where these systems were just developing and when false alarms rates were exceedingly high, to today. It's a gradual process. The systems that just came on the market today are considerably better than the systems from 2014. And I believe another question related to is that the systems are not preventing all the rear-end crashes today. Member Weener has made a distinction earlier in the beginning, is it is not purely about prevention, but it is about saving lives. With the high velocity differential, it will be very, very challenging to be able to alert the driver in time to respond, which we are talking about 5+ seconds, or for the system to activate emergency braking to prevent such rear-end crash. But what could happen is for the impact velocity to be reduced substantially to make a difference between a fatal crash and a survivable crash. So mitigation is really a big aspect, and that goes hand in hand with false alarms, which is why many automatic emergency braking systems today, even on passenger vehicles, activate at the very last moment to mitigate a crash, rather than to prevent it, as one way of preventing false alarms. So how do we get at this stage? NCAP represents one aspect, but before we can get there, NHTSA still has to complete the development of performance standards for forward collision avoidance systems in commercial vehicles. And as Member Weener has said initially, that the EU's NCAP is far more advanced, and it increases the requirements for the top safety rating increase every single year, from the existence of automatic emergency braking to detection of pedestrians. So the way we get there is to make the performance standards and the testing more demanding each year until we get to a stage where the system is capable of detecting a stopped vehicle when traveling at highway speed. So I hope that I've answered most of these questions in this area.
Yeah. Thanks, Sensar. That was a lot to kind of take in. I have a question here, I think for Ross, ATA. Did the fleets which haven't adopted AEB yet give any reasons? Is it that medium-duty AEB isn't yet as widely available as heavy-duty? Is that something you can address, Ross?
Sure. I've definitely seen like Hino, for example, and of the different Class 7 and 8 truck manufacturers. They also, the same manufacturers, manufacture Class 3 through 6. I have definitely seen in press announcements and previously with an ATA membership of committees that they have either said they were going to or they have made standard features for AEB. But I think what it really comes down to also, and which is why we've talked about the NHTSA research and the FMCSA research on heavy vehicles, mainly focused at Class 7 and 8, is because the amount of force and accident rates that they may be in. Not a lot of, and NTSB maybe even have research data on this, but I don't know how many times have you guys investigated an accident for a straight truck that was traveling at a speed or something of that matter, or how many of those straight trucks are on highway speeds going interstate, speeding at that rate or in so much traffic, more or less than a Class 7 and 8 with a 53-foot trailer that's also traveling in that areas. And how many accidents of I think you said around 3,700 accidents are related to heavy trucks. How many of those 3,700 trucks are just regular Class 3 through 6? I believe the research shows that the majority of those are Class 7 and 8s. So I think that's why the focus of AEB is on larger vehicles rather than medium size.
Okay, thanks, Ross. Another question that you probably could address, but also Todd or Robert could maybe chime in on. Someone wanted to know, what are you hearing is the biggest obstacle for fleets who've been reluctant to incorporate this technology in their vehicles? Why are they hesitant to do it? Any of you?
I think Robert also mentioned of that too, because there are a lot of fleets out there that's invest in a lot of safety procedures for their drivers. There's 2 fleets I know of specifically that invest in a lot of their drivers. They train their drivers to a standard that they see fit, and they develop better standards so much level, and they have pretty good records to stand by that. And some fleets may rather invest in their drivers more than the technology on the trucks. And like I said before, it's a business decision to do so much of this, because, I don't know how many trucks a fleet may have in this type of situation, but, in 5 years, if they put about 500,000 miles on, let's say, 1,000 of those trucks, there's a turning cycle of these trucks, and there's return on investment on these trucks. There's so many different aspects and just so many features and things to think about when a fleet of such a size is making a purchase on safety throughout so many different verticals within their fleet, that they know the best way to be as safe as they can. And sometimes that may be not installing AEB on certain vehicles of their routes.
Yeah, so Amy, I've got a couple quick comments on that. So one of the challenges you run into and was brought up earlier is driver perception, right? And so, the perception of the systems that have been in place for years, and the false alarms and the systems activating when they're not supposed to, unfortunately, it's very difficult to break down those perceptions once they're in place. But as was also commented on, the systems are getting better and better. So a lot of those issues are nowhere near as significant as they have been in the past. And so one of the things that needs to happen as you start to think through potentially implementing these is getting the new data, getting the information from today's systems as compared to even 5 years ago, and making sure that you're educating your drivers and educating everyone about how these systems are going to work, because the negative feedback from the drivers can be a huge inhibitor to companies wanting to implement these types of technologies. And then you add the financial piece to it, and when those two things are both kind of against adding these systems, it's a big challenge. So understanding the systems, educating the drivers, getting the current data on that information. And let me also mention one other kind of quick thing. So yes, inclement weather, are the systems going to work as well? I will tell you that the systems have improved significantly, and those weather-related false negatives and things like that have gone down significantly. But also remember, in good conditions, one of our biggest epidemics in today's driving world, and it's not just in commercial trucking. In fact, commercial trucking probably has less of this than regular vehicles, is distracted driving and fatigue driving. And reaction times and braking times that a human being has to take, when you add distractions to that, you double or triple the time it takes for someone to recognize a particular. Sensors don't have those distractions. Radar doesn't have those. Sonar doesn't have those. So the systems are always working, and they're going to recognize those risks before that distracted driver is. So, as much as we say there's challenges, which there are, and they're valid, and the drivers have valid concerns around making sure that the systems are going to work properly when they're needed. There's also a huge amount of added value that these sensors can give us that a driver can't, that a human being, not even just driver, human being can't compensate for. So the systems and the operators need to work together, and I think that's what we really need to focus on here. The systems aren't perfect, drivers aren't perfect, but if we put the two together, maybe we can find a perfect solution.
Great. I think that's a great comment, and that's what NTSB believes too. You're addressing driver behavior and combining it with technology, then we'll be close to, our goal of reaching zero crashes. So, there are lots of questions. What we're going to do for everyone is we are actually going to go through and answer the questions separately, independently to the people who've asked them. We have your names, so we aren't going to leave anybody wondering. But we do need to wrap it up because it's we've gone over, and I appreciate those who've stayed on the line. I did want to make one mention. There was a question about public transit and buses and what we're seeing on those, and I'm just want to let you know that in the future, probably within the year, we're going to do another webinar that's focused on buses, commercial vehicles, bus routes, transit buses. They are doing some good things, and we're going to feature some operators in that area, so stay tuned for an announcement about that. So this concludes our webinar for today. Look for a link to the recording and a feedback form in the next day or so. And on our slide here are some of the ways you can connect with the NTSB and get our information, learn more about what we have coming up for safety information investigations. I point you to the bottom right corner. You can sign up for our investigative reports as they come out. So that's nice versus having to go online and look for them. And once again, I thank all our presenters today and everyone who stuck on the phone for a little while over. We appreciate that. And thanks so much for joining us for our webinar, and have a great day.